Alright, last we left off, we were trying to figure out what x plus y to the fifth was. And I claimed that it was 6 terms. And how do I know that? How do I know it's going to be 6 terms? Well, if we look up here and look at this pattern, x plus y squared had 1, 2, 3 terms. X plus y to the third, right there, had 1, 2, 3, 4 terms. And x plus y to the fourth had 1, 2, 3, 4, 5 terms. So it's natural to think that x plus y to the fifth would have 6 terms. And also, if you look at it another way, you might see that it would start off the biggest term it can have is an x to the fifth, right? And then it goes all the way down. It goes some x to the fourth, x to the third, x squared, x, and x to the 0, all right. Normally you wouldn't write that. And on the other end, it starts over here and goes y to the fifth, and this would be y to the fourth, y to the third, y squared, y, and again, y to the 0th, okay? Now the only thing that we need to know is the coefficients. Well, recall that the last set of coefficients was in the 4s, was 1, 4, 6, 4, 1, right? So the next set we have to do is use the Pascal triangle trick and say, okay, well this term I said got increased by 1. That would be this guy. It gets increased by 1. So that's going to be a 5, right? The outside terms are still 1s. Those two terms get increased by 1. They're 5s. So what are these two guys here? Well, using the trick, it's 4 plus 6 is 10. So that's going to be a 10. Same thing with this. 6 plus 4 is 10. So now, if we sum all these things together, we have expanded the binomial x plus y to the fifth, okay? So it's kind of a cool trick. So now over here on the side, I'm just going to take this idea and write it out in a pattern maybe we can recognize. So I'm going to write x plus y squared, x plus y to the third, and before we even continue on, let's think about what are the coefficients of the things that I've written here. Well, x plus y, there's 1x and 1y, so we'll write 1 and 1, right? And x plus y squared, what was that? Let's go up. That was 1, 2, 1. And x plus y squared was 1, 2, 1. X plus y to the third was 1, 3, 3, 1, right? So far, so good. X plus y to the fourth we had, and we went up to x plus y to the fifth, didn't we? Okay, x plus y to the fourth was 1, 4, 6, 4, 1. X plus y to the fifth was 1, 5, 10, 10, 5, 1. And then we can make a guess and say, well, what was x plus y to the sixth, right? If we use our pattern, it's going to be 1, 6, 15, 20, 15, 6, and 1. And the only thing we're really missing in this triangle is this top thing. Well, if this is x plus y to the 0th, what would be x plus, this is x plus y to the 1. What would be x plus y to the 0th? Well, anything to the 0th power is just 1. So therefore, we have made this triangle, and you can expand it as far as you want. So remember, this is like combinations. It's a binomial expansion. Pascal's triangle is a very useful tool to expanding these binomials out really quickly. And if you just want to see what this is, this would be x to the 6th plus 6x to the 5th y. And if you look at the exponents, this x to the 5th plus y to the 1, that's going to equal 6, right? The exponents are always going to equal 6. So let's look at that. We have 15x to the 4th y squared, 4 plus 2 is 6, plus 20x to the 3rd y to the 3rd, 3 plus 3 is 6, plus 15x squared y to the 4th, plus 6x y to the 3rd, plus y to the 6th. Actually, this one here is y to the 5th. Okay, but I think you get it, and that's it.